everyone, my name is Layla Airola, and today I am presenting on my capstone. So thank you all so much for being here. And my capstone, I did my internship at the Student Sea Glider Center, which is a student-run lab in UW's School of Oceanography. So today I'm going to be talking about my research that I did and a little bit about my internship as well. And I'd be happy to take questions either throughout or at the end. So here's my poster overall. And so overall, my title is Brain Drain to Brain Gain, Preserving Institutional Knowledge in Student-Run Environmental Research Organizations. And my site supervisor was Sasha Saroy, who's a professor at the School of Oceanography, and my faculty advisor was Philip Bruner from the Foster School of Business. And so just to provide some background, because a sea glider is not typically a known thing. The Student Sea Glider Center is a student-run lab in UW School of Oceanography, as I said, and you might be wondering what sea gliders are. And so as you can kind of see in this logo, sea gliders are underwater autonomous vehicles. And so we at the Student Sea Glider Center and other scientists pilot sea gliders in oceans and other water bodies, but primarily oceans, um, to collect oceanographic data. So on the sea glider, which is, flies autonomously, we program it to go from one place to another, and it does that route while collecting data the entire time. And so it can collect data from whatever sensors you put on it. So typically, our sea gliders have chlorophyll, temperature, depth, salinity, backscatter, a lot of different sensors that can be added to it. And so it collects data, and this helps influence our, climate understanding of climate and currents and various other aspects of understanding our oceans. And so the Student Sea Glider Center is a center I've been involved in for the last 3 years as a chief business officer since its founding. Um, and so I've been here for quite a long time, and I've seen this problem of institutional knowledge loss, which is what I am researching and studying today. So this is a problem that's very relevant to myself as I have experienced this problem and I'm graduating in a few weeks. And it's a problem that I think about what will happen when I leave. And so that's just some context and background of why this type of work is important. And so just to kind of frame it a little better, so students who are from a variety of majors join the SSC's three teams, which is science, technical, and business team. And they come from a variety of majors. Typically, they're underclassmen when they first start, and they're primarily undergraduates. And so these labs, like the SSC, or as I call them, student-run environmental research organizations, can give students really useful skills and experience for their future careers and endeavors. But because students graduate, these programs face high turnover. And this is quite a big problem because knowledge loss um, is a really existential threat to a lot of different types of organizations. So it makes it where organizations can't build on the knowledge that they have attained in the past. They're always having to rediscover previous knowledge. And so this is a major problem for us. And so my research objective during my internship was how can how can the Student Sea Glider Center and other organizations like it better preserve institutional knowledge in these types of organizations? And in my specific context, I was studying if an onboarding or a training class can better preserve institutional knowledge. And so my methods were that throughout my internship, which took place over winter quarter, but for, as I said, I've been in this program for 3 years, so I have additional information. But throughout this, the SSC piloted a different type of piloting as before, but piloted a class that was a training course. So typically, students just joined the Student Sea Glider Center and joined one of the three teams directly without an onboarding program. But this year, we decided since the SSC is increasing in size and complexity of the work that we do, we thought that it's time to try out a class. So I studied the efficacy of the class that had for the first time in winter quarter with 18 students who were interested in joining the lab. And so I surveyed students at both the beginning and end of the quarter on their self-reported competency in 14 subject areas relating to the lab and the course's content. So here's a photo of what the class looked like. Um, and so my results from here were that um, between before and after the course, as I measured, competency in these 14 different subject areas, which include the responsibilities of the different teams, which I'll talk about in a second, but it includes things like piloting a glider, ballasting, data visualization and analysis, and a variety of topics that are important for all of our different teams. And so I found overall that there was a 25% increase in knowledge and self-reported competency from before to after the class. And so yeah, how I measured this is through a Google form I sent to them at the beginning and end of the course. And it was on a scale of 1 to 5, similar to a Likert scale, with 1 being the lowest and 5 being the highest. So this is averaged for all the students, all the 18 students, averaged on a scale of 1 to 5. And all these were statistically significant. And so here is a different graph. It's complicated looking, but it's pretty understandable. So I'm going to so this green bar here is just extrapolated down to here. It's the same bar. So this shows after the Sea Glider Basics class how self-reported competency compared to students who were in the SSC and had been in it for any number of years. So this could be people who were in it for 2 quarters or people who were in it for 9 quarters, like myself and one other person. So there's a real broad, scale here of how long people have been in the SSC compared to people who've just been in it for 1 quarter. But overall, there's an interesting phenomena here where you can see that the overall competency is much more well distributed and well rounded for students who had taken the course than students who were already on an individual team. So, as you can see here with the business team responsibilities in orange, the business team's knowledge is relatively siloed. Like they do not have high competency in other areas because the business team does what the business team does. We don't typically stray into other areas. There's more interdisciplinary work between the technical team and the science team, but overall, you can see how there are higher competency levels on average in the teams that is what they do, which makes sense. But overall, the Sea Glider Basics class helped us increase the overall amount. It made it more well-rounded. So where students enter the SSC, they come in with a more well-rounded breadth of knowledge, which is really useful for encouraging interdisciplinary learning and understanding what other teams do. And so we're really happy with this result. And so, as someone who's in a leadership position at the SSC, um, these results of a 25% average increase in self-reported competency and how it was a more well-rounded knowledge base than direct entry peers was really positive for us. And it also helped us formalize the documentation and help us create curriculum that's really important often for students. And so it was really useful for us, and also it helped reduce knowledge loss because as students graduate, such as myself, this served as a useful time and opportunity to be able to to pass down knowledge in a way that instead of working one-on-one, which is not extremely scalable, it provided an opportunity for team leads who were the instructors of the course to be able to just pass down knowledge at once. Which helps expedite the students in the course's learning and hopefully helps reduce institutional knowledge loss in the future, as now basically less experienced members have more knowledge than their counterparts who just joined a team directly. And also, um, a student lead, um, a student lead, the student leads benefited from teaching the course as well, because teaching is often known to encourage and increase the level of knowledge that a teacher, um, that basically teaching people helps increase the level of knowledge. And so this was really useful as it also helped them practice science communication and teaching skills for maybe some of our student leads who want to go into academia. And so overall for implications, this type of student-led training is an exportable strategy to be able to give this type of method to broader programs. So some of the universities have wanted to start programs similar to ours, and we can share our curriculum materials. It is much more scalable than one-on-one mentoring. But also, near-peer mentoring has also shown that it's really useful because typically the students relate more to the team leads who are just a few years older than them, if that. And it also helps give this team leads leadership and ownership and additional skills that they wouldn't have had before. And so overall, this has resulted in the SSC planning to operate the training class in future years. So we decided that from these results and overall positive feedback as well from a variety of different stakeholders that we're interested in operating this class in the future. And also, other programs like it can benefit from these findings and look into developing similar mechanisms or models of knowledge transfer similar to ours. And so, yeah, this is a culmination of my capstone project, and I just want to say thank you to my site supervisor, Sasha, my faculty advisor, and every other member of the SSC for being my survey participants and helping me, and also just family and friends and the SSC's funders and supporters in the school of oceanography and the applied physics lab and the student tech fee. So yeah, I'm happy to answer any questions now. Thank you so much for listening.